Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be building a game show buzzer system. So if you ever wanted to play a game, have a game show of your own with your friends, this is going to be the thing to do it. It's going to add a lot of dynamic elements in terms of being able to play sounds and hopefully play some video. But let's start with the basics. So let's get right into it. So first thing that we're going to do, so just kind of a layout of what we have here. And I'm going to say this right off the bat, it's been tough getting this going because for some reason it's been fighting me. So you will notice that some revisions are in there, so this is going to be our game show for today. Okay, I just needed some buttons that I could push, and pretty much it's actually going to just be 3 players. And then it's going to be 1 in order to reset it, so that way the system's ready for, the next play. So the idea behind a game show buzzer system, or what they call a game show lockout system, is that when a player actually, whoever the first player is that presses the button, they are going to lock out the other players from actually being able to buzz in. That way you can really tell who actually buzzed in first. So we're going to be setting this up through Python, and we're going to be using this Raspberry Pi 3, but realistically, 3B, but at the end of the day, we could use a Raspberry Pi 4, Raspberry Pi 5. It doesn't really matter. And we have some lights to go along with it. So we're going to start small by just doing basic input and basic output. And this builds upon the last video that we did, where pretty much we just lit up some LEDs and took some input from some buttons. I did want to do something a little bit more extravagant in terms of trying to integrate, Pi game, PY game, to be able to do it. So I have some code written, but we'll see how that goes. And actually, I could even show that to you, assuming it's even going to come up. There we go. Oh, I did it with the number pad that doesn't exist. So pretty much for game show. Oh, I don't have any music on. All right. So pretty much for game show .py, which is the script that we're going to be working in, and we're probably going to end up just copying it and deleting a bunch of stuff. The idea behind it is that it would also show some video output, so you can run it to a screen and actually show who was the first one to click in. And PY game is good for that because you could actually technically write your own games using Python. So it has a lot of commands to be able to do some basic functions like showing text on screen, things like that. And then actually throwing in a buzzer sound effect. So, it's going to be something that we don't necessarily have to go this in depth. So I'm just going to start, I'm going to create a new file, and let's just do it that way. All right, so now we're back at the screen. Let's clear it out. And we have 2 things that we actually have to go through. We have to decide what pins we're going to use on the Raspberry Pi, and then we have to program those into the file. So let's go in and create a new file. We're just going to do it in the local directory. And let's call it... let's call it first. .py. And first thing that we're going to do is we're going to put in the shebang command. So we're going to do /user /bin /python. And then we need to import our utilities. So we're going to do import, and we'll do rp lowercase I .gpio as GPIO all caps. And we'll obviously want maybe a sleep command, something like that. So we'll do import time. Let's just leave it as that for now. And then pretty much what we could do is define what our individual pins are going to be. So we'll do players, and we'll define a list. So if we actually go over to the Raspberry Pi pinout that I have on the other machine here, and this is for the Raspberry Pi 2 header, but they're actually all universal. We're going to decide from these pins. Now, right now, I don't believe, I don't have anything defined. I have the LEDs plugged in, but we can pretty much choose all a carte blanche of what we actually want. So we just need 4 pins. So we need the 3 pins for our players, and then 1 pin indicating that it's ready to play. So let's go ahead and do 2, 3, and 4 for the players. So we'll switch back over here. We'll enter 2, 3, and 4 for our players. And then we'll have our operator. And that's going to be 1 other pin. Well, we probably should have just figured that out when we were here. Let's do pin 17. It's one of the ones we used last time. That doesn't look like the Raspberry Pi 3B. Wait for it. There it is. And we'll do 17. That did not type the 1. So those are our buttons. Now let's define our LEDs. So let's say LED players. And we'll give it another list. In this case, I've already chosen these, so it's going to be 26 for player 1, 19 for player 2, 13 for player 3. And the operator LED, actually, we're going to call it LED ready. And we'll do that as 21. So let's go ahead and get these connected. So if we switch back over here to our pinout, it's technically upside down from what I have here. And obviously if I try and turn it around, I'm going to have to unplug it. So just in your mind, turn it 180 degrees. So this row right here is technically the inside row because it expects you to be holding an SD card up. So 2, 3, and 4 are going to be these pins right here. So let's go ahead and make that full screen. And let's get those connected. Right, so it's starting from here. So this is 3.3 volt. Then we will have player 1, which is red. We're going to plug into GPIO pin 2. Player 2, which is yellow in this case. We're going to plug that in 3. And then blue, which is player 3, we're going to plug into 4. Perfect. So now if we look back at this, 17 is after a ground pin. So we're going to skip 1 pin and plug in our green wire in this case. Oops. Transition. Let's see. So we're going to skip that 1 pin right there. And we're going to plug in our green connection. Now, we do need a ground because these are actually going to have to make an electrical connection to something in order to activate the particular, the pin. So we have this black wire here. Let's go ahead and connect that to the ground. Right, so it's all in a row. Very nice. So before we get too deep into it, we should actually just test it and make sure that it works. So let's go back over to our KVM. Let's switch over to our Pi and let's program that. while this is here, I'm gonna just pull up a reference so I'm not going crazy. Okay. So now we've defined LED ready as 21. We need to initialize our pins in order to define what the actual pin direction is. So there's a simple shortcut that we're going to use, and that's the reason that we used a list in order to define our players in this particular case. So first, before we initialize the individual pins, we'll do GPIO.setMode. And we will set it as GPIO.BCM to let it know that we're talking about the GPIO numbers and not the board numbers, board pin numbers. Next, we're going to use a for loop. So we're going to do for pin in, and then we're going to say players, which is just the variable that we defined that holds our list. So it's going to take each one of those elements and it's going to bring it into the pin variable, which we'll then be able to use just like we would normally. And then we can get that set up. So we're going to do GPIO.setup, and we're going to do pin GPIO in. And we're going to use the internal pull-up resistor in this particular case. So that will bring it high, so when we press any of the buttons, it will pull it down to ground, and that's how we'll know that it's actually been pressed. So we'll do pull, up, down, and that will equal GPIO.PUD up. Make sure I spelled it all right, because I'm looking at two things with a bunch of lights in my face. All right, so now that we've set up those individual pins, we have one more pin to set up, which is the operator pin. So we're just going to define that normally. So we'll do GPIO.setup, pin, GPIO.in, perfect. So now we've at least defined them as inputs. So next, we can create a loop and go through it, but let's define our LED outputs. So we're going to do effectively the same thing. We're going to create a for loop, but in this time, we're going to use LED players as the input or as the list that we're going to use. And we're just going to do GPIO.setup, pin, yep, GPIO.out, and that is it. And we'll do the same thing. GPIO setup, not pin. And actually, I put ping up there too. So I spelled it wrong, and it's not actually what it's supposed to be. So up here, it was actually supposed to be operator, because that's what we did it with. It's not inside the for loop. Down here, we're also not in the for loop, so it's going to be LED_ready. Excellent. Just to make everything simple, we're just going to put cleanup down here. That way we don't forget about it. But that will let us run it right now. Meow. Alice says hello. So, gonna say hello? What are you doing? All right, come down here. She's so funny. So this will let us actually run it right now. So we can escape, write that out. And now, in order for us to run it, we actually have to give executable permissions to this particular file. So we called it first.py, but we're just going to do chmod and then +x, which will just add executable permissions. So whoever had write permissions, read permissions, that will all stay the same. The only thing it's going to tick is the actual executable permissions. So now we can do /first.py, and let's see what it does. And it hates it. It says physical pull-up resistor is fitted to this channel. And this may be because of our channel selection. So specifically, if we go back over to the actual pinout, on 2, 3, and 4, we see that it's SDA, SCL, and GPIO G-clock. So I don't think it has an issue with this, but it may have an issue with these two right here. So we may need to shift our pins around based on what is actually already assigned there. There is a way to actually use a user config file to be able to change that pin assignment. But at this point, let's see if that's actually the issue. So let's actually just delete those 2 pins and just see if it actually goes through successfully. And it is on our input because it's talking about a pull-up resistor. And we can have a list of length 1. I didn't do caps. And we see there were no errors. I didn't do anything, but there were no errors. So let's choose some other pins just to make life easy. So back on our pinout, right? And it's these top 2 for player 1 and player 2. We could use 27 and 22, which are just below our operator pin. And that'll work just fine. So let's go back over to the Pi 3. And let's edit our file. And we'll do 27 and 22. Let's run it again. And we see there were no errors. So we're good in our pin assignments. But that's not really going to decide any games, high stakes competition here. So let's actually add some logic here, just so it starts doing something. So first we're just going to have it run once. We're not going to integrate the operator pin to actually do anything, but we'll stage it so that way it could. So let's just do... Oh, I didn't do insert. So I'm going to do continue equals false, or excuse me, true. And then we're going to do while continue, and we're going to pull the individual pins. So we want to actually find out what the pin state is, and first one to actually choose it is the one that we're going to go with. So let me verify. Yeah, the issue was that I actually was doing the pin.state. So let me verify this. So we're going to do GPIO dot input, and we're just going to do the pin number. So actually we do need to do our for loop here. So we're going to do for pin in player. We're just going to take whatever our button state is and just output it directly to our GPIO, so to our LEDs. So we're going to do GPIO dot output and we'll do, okay, good. So it's going to be just pin. In this case, it's not going to be pin. It will actually be the same index. So let's just have it so any of them do it. We'll just light up the green pin, which will be the operator pin. So we'll do LED ready. GPIO pin input, so we're just going to take the input, pass it through to the output. And we'll do that for each one. It won't necessarily work, mainly because we won't actually have a thing. So let's just do best laid plans. So I literally was spending like the past couple hours trying to get this other thing to work so I could just show it, but we're gonna write it, and sometimes it's a little more painful than it needs to be. But you know, such is programming. So let's do this. So while continue, we're pretty much going to wait for the first button press. On the first button press, we are going to set continue to stop, and we're going to log what our winner is. So let's do winner. Actually, let's do, we don't have to set it because we're just going to set it. So, and what we want to do, let's go over to our computer because I would just want to look this up. And specifically what I want is I want to get that did not type. I don't know why this is going so slow. Let's see. So we want the index value as we're going iterating through our for loop. And pretty much what it says to do is we put our index, comma, x in enumerate, and we enumerate our index list, which will give us the two particular values. So let's go ahead and implement that. And what enumerate, yeah, literally just means that it will give you two values back, which is a tuple. Or a double. I don't remember. Tuple is three values back. Stop meowing. Be nice. So we're going to set this to enumerate. Open, close. And we're going to set a value here. So we're going to do index, comma, 10. So it's going to give us back the two values. Right? So what we're going to do is we're going to set winner to our index. So we'll just set up a simple if statement here. So we'll do if GPIO pin. And another option is we could just do break instead of doing continue, but we'll do both. I mean, realistically. So we'll set winner equals index, right? Continue equals false, break. And break will get us out of the loop, but the thing is we are in a for loop as well. So it may not, so it'll stop. What the break is going to do is it's going to break out of the for loop which will stop checking the next entry. So technically it is giving a slight priority to whatever the lower number pin is, if there's a tie, but the goal is that we're not going to put a delay statement in here. And the idea behind it is that as soon as it hits the first instance of somebody pressing a button, it will just stop, and then we can light up the light for that pin. So before we go out here, let's do GPIO.output. We'll do LED ready 1. So we'll set it to true, or we'll do GPIO.high. Okay? And then let's go down here. So outside of our while loop, because now we've exited our while loop because we set continue to false, we broke out of the for loop, and now we know what our winner is because we set the variable winner to the index of our winner. So what we're going to do is we're going to do GPIO.output, and we're going to choose our pin, but we're going to choose it from LED players, but using the index that we got from players. So we're going to do LED players with our index being winner. Then we're going to do GPIO.high. And then we're going to turn off our other, make sure all of our other LEDs are off. So in this particular case, we'll set turning them off before we actually get started. So let's do the same for loop that we had up here where we set up all of our pins. Let's just have it turn it off at the same time. So we'll do GPIO.output pin, and then GPIO.low. That way everything starts out low. Then we turn on our actual output pin for the LED ready. And then we enter our loop. So all of the LEDs except for LED ready are off. So let's turn off our actual LED ready light here because we're no longer ready. We have a winner. And that's it. And then we'll just clean up and exit. So we'll run it once. So pretty much every time we run the script is one play. Let's see if we made mistakes. Syntax error, invalid syntax. I think I didn't put a space and it needs it. Oh, continue is a keyword. I can't use continue. Let's just say next. Which may also be a keyword. Let's see. Oh, I didn't update that second instance. So what continue will do is it actually will just skip the rest of the code in that loop cycle and go to the next loop cycle. So that's not a good word to use. All right, so we do have a green light lighting up, so it did become ready, but the problem is name player is not defined. Did you mean players? And the answer is yes, I did. So that is a typo. So let's add that S here. All right. And hopefully that made it go. It did not wait. So what's going on? The answer is I'm not entirely sure. Let's find out. It looks like it's kind of working. So let's see who our winner is by just printing it out to the screen. because it looks like it's cleaning up before we actually get there. So down here, let's do sleep. And let's do 30 seconds. That way, at least it stays on for a little bit. So we do see one is active. So I'm just curious. It should be timed out to sleep. So I think I have these wired backwards. So what these actually said, I'll show you. I'll show this to you full screen. So down here, so I have it connected to the normally open when I probably should have had it connected to the normally closed. Again, I couldn't get this working before this. I did try and spend some time to do that, but couldn't do it. And that's not a solder bridge you see. That is actually on the board below it. It just dripped off. So, and this is two of them stacked because this is one of the ones that got accidentally, I got glue actually in the button itself, so it's seized. So on this one and the one on the other end, I had to cut off. But, you know, it is what it is. So we could actually just correct this now just by moving over the wire. And I'm thinking about just doing that so that way I'm not causing problems with this whole thing. The other option is we can actually reverse it. So right now this is holding it low, but I like the idea better of having it be a falling edge opposed to it being a rising edge, just because we don't actually know how fast the voltage would go up. We do know how fast it would go down, just because it's going to be a lot more, it's a lot easier to drain it than to fill it. So that sounds weird, but it's one of those things. So let's actually just correct that. So I'll zoom this back out. I'm gonna pull out a soldering iron really quick. Much to the chagrin of a particular cat. And I probably should disconnect this from power, but to be honest with you, since everything's going to ground anyway, I don't think it's going to hurt it. Then we get to see my lovely soldering skills in spaces that are incredibly confined. So we'll let this heat up for a second. While that's happening, I'm going to take a sip of water. All right, so it should be hot enough. So let's see. My cat has been asleep the entire day, and as soon as I start streaming is when she decides to wake up. So that is how that goes. All right, we're just gonna move these one at a time. Meow. Okay. Now let's move this out of the way. All right, so now when we run it again, we should actually see it work normally. Just based on our test, hopefully that's the case. So now we see it's green. And if we press red, we see red comes on. It will stay on for 30 seconds. I'm going to escape out of there. Let's do it again. It says it's already in use, but it's going to go ahead and do it anyway. And we see As soon as we press the second button, it turned on. It's going to do the same thing. Oh, it still went here. Okay, it's ready. And now we have blue. Okay, so it is locking out based on that, but we want to make it so that way it waits for the ready button press from the operator and then goes back to a ready state in a continuous loop without having to re-enter the program. So to do that, we're actually going to put it in an overarching while loop. So we're going to keep everything up here, but we're going to go down here and we're going to do while true. Okay, and then we have to tab indent everything below it that we want to keep it. Okay, and we're not going to put in a sleep command here. All right, and we're just going to do, so pretty much while true, and then we're going to wait, and this is actually where we'll add a proper sleep command. So still inside of the while loop, we're going to do while, and we're just going to say the actual pin and just read the pin directly. So GPIO dot input operator right? So while that is not true, we'll sleep. So we're actually, and I gotta say, time.sleep 1 second. Right? So you'll have to hold the operator pin for 1 second in order to get it to go. We could do a lower precision, something like that, or we could do a 0.1 and make it so it's pretty much instantaneous. But at the end of the day, you know, I think that should be fine. So let's do 0.1. Okay, and then it will loop again. So we need to add some initialization here in order to make it actually reset everything to the ready state. And you noticed how we turned off all the LEDs before, and we actually set the operator or the ready light to high. So let's go ahead and do that. So we'll do GPIO.output. Let's turn off the ready light, or turn on the ready light, excuse me. So LED ready, and we'll do GPIO.high. Right, and we'll do our for loop again. So we'll do for pin and LED players. GPIO dot output pin GPIO dot low. Right, and once it finishes that, it's just going to go right back around, and it's going to loop and go straight into the next game. So let's give this a shot. It should not exit every time we do it. We should actually have to go out. So what we could also do is put in a try and a catch so it cleans up. That way it doesn't give us those errors every time we re-enter it. And the way that we do that is we just do try, indent everything again, whoop. Right, and then we're just going to do accept. And we're going to bring up our GPIO cleanup and tab that in. So pretty much any exception that it experiences, like a keyboard interrupt or anything else like that, it's just going to immediately clean up the GPIO pins and be able to run with that. And I think that that's going to be a much more elegant way to exit and re-enter without seeing those particular errors present themselves. So let's go out of here and let's actually run it. Right, and you see how it said that channel was already up? That's what the error I'm talking about. So let's exit out of there, enter again, and now we see there's no errors. Now, the first run, we just had it go straight into the game, right? So we don't have to press this, and it has no effect on what we're actually doing. But as soon as we press a button, right, we see it actually goes into it. We can press whatever buttons we want, and nothing else does anything. But as soon as we press this, we see it goes straight back into the game, and we can press the next button. So it's doing what we want. It's actually showing who is winning, and it's making sure that two people can't go in at the same time. So if we press both of these, although I think these buttons have different sensitivities, we shouldn't get a tie, but it does look like one is getting particularly a little bit of favor over the other. And that's kind of why I wanted to originally use, based on the what I was trying to do before with actually adding falling edge interrupts, which I tried to prepare for this video. But the problem was it kept giving me errors every time I tried to implement it, and I couldn't actually make it work. So I think that this is a bit more of a brute force solution to it, but it's definitely more reliable in terms of not having special requirements that we would have to work around. So going on from here, let's say we actually wanted it to play some kind of notification when we actually had this come through. I'm going to pull up our original file here, and I'm just going to hit Control-C to go out of that. We do see the light turns off, indicating that it did clean up. I have Nala sitting here in my lap. She wants to be a part of this video. I don't have a camera that can point down at her. So pretty much what we can do from here is we can actually pull up a PY game. We can also potentially have it launch another application to be able to play it. But what I do have is a buzzer that can play. So there's some initialization code that we can actually steal from the other script. It's not going to be easy to copy and paste it, so I'm just going to actually pull it up on another screen, and we'll just go through it that way. All right, and that's going to be our buzzer sound. So we're going to import another actual library into this. So right now we just have these three. So I'm going to import PY game. Right, and we're also going to import OS. Right, and that just allows us to actually interface with the underlying OS outside of our particular running environment. And then we need to define what our sound is going to be. So in this case, let's call it buzzer sound. And we're going to call it buzzer.wave. And close quotes. And I just have the actual audio file. I preloaded that on the Pi, and it's just in the same relative directory as the actual script that we're running. So there's no need for a path here if it's in the same folder that we're running the script from. So next we actually need to set up our sound as part of this. So before we actually set up pins, anything else like that, let's get our sound set up. So we'll do pygame dot mixer underscore dot init. Right, and that will get our audio mixer set up. And then we will say buzzer sound. I have a cat who's trying to... We're going to do pygame.mixer.sound with a capital S, and we're going to do buzzer sound. Excellent. So now that should be initialized. So when we actually want to activate it, right? So down here, when we choose all of this and we break, let's just play the buzzer sound from here. So we're going to do buzzer sound. Dot play. And that should be it. There shouldn't be any need to actually go through there. But we do have to add an additional thing, which is we need to actually, oh, maybe not. Yeah, that's not part of it. So that should be it that we need for the actual audio. So let's escape out of this and let's try running it. Let's see if it works. Right, so it says hello from community because we're using Pygame. We can also do display, and maybe we'll try that in a second. I'm actually interested to try it. Now, oh, let me pull this up because I don't know. It's supposed to come through the actual... yeah, it's supposed to come through the actual PyCapture. So I'm just going to turn it down to begin with. Just so hopefully it's not blowing out everybody's ears. And let's just see what it does. That was probably pretty loud. But it did come through. So when we actually clicked our little button, we see that it's now outputting an audio signal, you know, whatever sound we choose, to indicate that a button was pressed. Now, it does seem delayed, and I will say that I do have some silence at the beginning of this. I just downloaded it from a stock sound effects library, just so I have license to use it. But if I cut out that noise, it wouldn't, that additional space at the beginning, it wouldn't have that delay. So we could add additional sound effects. We could actually create a separate list, if we wanted to, of sound effects for each person, if we wanted to have that kind of indicate who pressed the button first. There are other things that we can do with this, like in the past I've actually used it to control relays and have it turn on a light above the person, or light up their podium, so that way it indicates who actually has it. But I wanted to just try Pygame. Since we're already loading the library anyway, it might not hurt to actually try and output some video. So let's exit out of here, and let's go ahead and just go back into the editor, and let's see what we can do with that. Now, it doesn't necessarily need to be the best quality ever, but we definitely want it to draw us some text. So I'm going to go to my little example here, and let's see if we can actually get this to go. And I do have some slight changes to make to what we've already done, which is we need to actually add an additional init function. So this comes after our sound because it is actually initialized separately from our sound. And we're going to do pygame.init. We're going to define the width and height of our screen. And this is just going to output directly to the screen. So we're going to do screen width. In this case, I'm going to match the current screen width just because I think it will be okay. But we can make it larger if it doesn't work out. So I'm going to do 1280 just because it's not actually, I'm up-resing this before I take it into OBS in order to show this. But the actual native screen resolution is 1280. and then screen height. And we're going to make that 720. And mainly I do that just because the text is bigger. Then we actually need to say what we want to do with it. You know, we need to apply those somewhere because we just set two variables. So we do screen equals pygame dot display dot set set mode, excuse me, and then we do double, which is screen width, and screen height. I put too many E's and no underscore. Right, and then we actually close our parentheses on the initial call. So, and what we can do is we can actually display something initially. So let's do cat was still sitting on my lap biting me the whole kinda. So let's do pygame dot display dot set caption, and let's just call it buzzer system. I didn't put it in close quotes. There we go. Okay. We actually need to tell it what font to use. I think we may be able to just make it choose on its own, but we may actually have to define this, which may mean we need to install a font. So let's try it out. So font equals pygame dot font dot capital font. Let's do none, and we'll make it 72 in size. All right. So now we got that. So we have our sound playing. And we need to actually have it do something, right? Otherwise, it's not going to show us anything. So let's do this. Let's do, we'll define a function. We'll do display winner. And the winner will be player number, right? Which actually will be our index. So I'm just going to call it index. All right, and we're going to do global in order to take in our actual LED outputs and, or excuse me, our player buttons, all of that. So we'll do let me see. Wait, I'm reading the wrong thing. No, we don't need to do that. Yeah, so our winner is just going to be our index, and we're going to do screen dot fill, and this is the screen that we initialized before, which I notice has a typo. It's that screen. So we're going to fill it, and we're going to just give it a tuple, which is 3 values. So 0, 0, 0. And then pretty much that's just going to be a black background, and it's for RGB. That's what those 3 values are. So you can actually change those to your liking if you don't want it to be black. Then we're going to do text equals font dot render. And we're going to say we want it formatted, so we put an F, and then we put our open quotes, and we'll say player, and we're going to put in the player number wins. And actually, yeah, let's call it player number because we're going to add 1 to it before we actually call this function. Exclamation point and close quotes. Then we're going to do true And then we got to give it a color, which is going to be white. So it's just going to be another tuple, which is going to be 255, 255, and 255. Again, if we change those values, we can make it a different color as well. Right, and that's our text. So now we've rendered our text out. We want to make an actual rectangle or something to put it on. So let's do text.rect, and we'll do text.get rectangle, and let's do center equals screen width divided by 2 screen height divided by 2. Right, so that creates our rectangle. And now what we can do is actually blit that to the screen. What blit actually does means that it's going to load it to the screen memory. So it's just kind of like uploading your saving your work. So we'll do screen.blit, and we'll do text and text underscore rect. And now we just saved it, but think about we want to actually output it. So what we need to do is flip. So there's 2 frame buffers. So there's the frame buffer that you're editing and the frame buffer that's being displayed. And you just swap between them. So think about it like hitting the print button. So we're going to do pygame.display.flip. So we have our function to actually modify the screen itself. And it's only going to show it whoever won last. It's not actually going to clear it, but you know what? That's okay. We're going to go down here to where they actually win. And what we'll do is we'll actually run it before we break out of this. So we're going to do display winner. And we're going to do index +1. And that's our player number. So let's try this. Let's see if it actually works. All right, and we are watching the actual output of the screen. So let's see if it actually loads. Let's see if it does things. Does not look like it liked it. And we're gonna have to find out why, because it looks like it just exited. It didn't actually do anything. So let's go in here. We're gonna actually we're gonna do accept as E. It's not an E, that's a 3. I believe it's a exception as E. Let me look that up. I just want to... It would just be ironic if we added things to handle exceptions that caused exceptions. So, you know. Let's see. So, as error. So it is just exception, and we're just going to do it as E. And then what we're going to do is we're going to print E. So let's try that, and then it'll clean up and exit normally. Right, so we see it's here. Currently it's green, so it's ready to go. We're going to press our button, and we see that pygameSurface.surface object has no attributes rect. Okay. So our rectangle thing is an issue. So it's the surface.surface. So I'm not sure that we actually need to do this one. Let's see. I'm just curious. If we comment this out and we get rid of it out of here, will it go? I mean, it may not be perfect, but let's see what it does. Yeah, so it's a destination that's an issue. And that's what the rectangle is doing, is it's actually adding the background. Otherwise, it doesn't know where to put it. So let's put that back, and let's actually look this up. And just so you know, the set caption, all of that is actually the title of the screen if we were running this in a regular operating system. I'm just going to make it happen again. So pygame.surface object has no attribute rect. So I don't know where we put surface. So let's go back over to the computer and let's just go do a quick search. Mouse. This is the slowest typing I've ever seen in my life. There we go. Right? So has no attribute rect. So if we do screen instead, so this is just pretty much doing the size of the screen. So let's go back over here and let's actually try setting that. So instead of text, let's do screen. Okay. Looks like it tried to do something. Still says that. Well, let's go back over here. And Pygame has some extensive documentation in terms of what you can actually do. You can draw, you can display, color, you can actually use touchscreen input, things like that, and be able to display it full screen using graphics acceleration, all other kinds of really interesting things where you're just coding normally inside of Python. So it's a lot of fun to be able to do things, you know, it can support cameras, things like that. And it's a great way to be able to build really straightforward games that are easily editable and, you know, are uniquely yours. So let's just see what we could do about finding an actual local example, or an example here about actually putting text on the screen. This is, I don't know why. Why is it so unhappy? I'm gonna try unplugging this and plugging back in. Let's see. Let's see. Oh, look at that. Well, I'll tell you what. I think this is going to take a little bit, but it is something where I'm going to actually post a quick gist on this on GitHub. And what I'll include in there is the code, if I do get it working, on how to actually make it right out to the screen. Or depending on how complex it turns out to be, I may actually just do another stream about it. But the idea behind it is, I mean, the same. So we'll just delete that really quick. We'll have a working example that I can actually just post as is. And I think that that's going to really be something that, you know, I think a lot of people might enjoy. Because if you just have a funny sound that plays, you know, people tend to really get into it. Ask some good questions, things like that. You know, I think people will really enjoy what it is. And I know that that's worked for me in the past. You know, I did this in college for more than a couple of other people for their senior projects for television classes. So it was a lot of fun. So let's see. Let's just make it work again. Right. Player 2 wins. Oh, there's a struggle. Player 1 wins by default. Player 3 won. Player 2 won. So, you know, what I actually did in order to make this more ergonomic is I took a dowel, right, about 6 inches long or so, and I drilled a hole through the center of it, and then ran the wire through it and put the button on top. And that way they had something that they could hold to be able to actually activate the, you know, for the game. And, you know, I put common cable connectors, things like that, in order to make it work. So, but it was very reliable. It worked. It added a lot of visual elements. And again, you can add whatever you want to this. Control lights, you can control other things like that. It's just a matter of what you put in the code. So that's going to do it for today. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.